This video is part 2 of evaluating inverse trig functions. So our goal is to be able to do exactly that, is to evaluate the arc sine, that's the inverse of sine, arc cosine, and arc tangent of functions. And our prerequisites are that you're able to label points on the unit circle where the angles that are multiples of pi over 4 and pi over 6 intersect that, and to be able to evaluate all 6 trig functions if you're given or input angles that are multiples of pi over 4 and pi over 6. So if you don't know that, first it's going to make this a little bit more difficult. The directions for these problems will be to evaluate or simplify. Now in the previous lesson or video, we evaluated the arc sine of a half. Today we're going to add one extra component, which is going to take, in this case, the cosine of this inverse trig function. Now, let's make sense of the problem before we solve it. First off, the arc sine of a half must output an angle between or including negative pi over 2 to pi over 2, some of our prior knowledge. And the cosine of that angle must be in between negative 1 and 1, or including those values, negative 1 or 1. Here's why. The cosine and sine function have a range of negative 1 to 1. So the output of cosine of an angle has to be in between or including negative 1 to 1. So in our previous lesson, we found the arc sine of a half. I'm going to draw a unit circle here. If the circle has a radius of 1, that would imply that this point here is 1, 0. Now, when I see arc sine of a half, this 1/2 represents, because it's arc sine, represents a y-coordinate on the unit circle. So there's two locations or 2 points on the unit circle that have a y value of a half. Now, arc sine must output an angle between negative pi over 2, it could include negative pi over 2, to pi over 2. This is the inverse trig function, so each input can only have one output. That's why there cannot be more than one answer for this problem. In another video, I'll show you why are the outputs what they are for these inverse trig functions. So this angle here, arc sine of 1/2, is going to be pi over 6. That's one of the angles that we're supposed to be familiar with, angles that are multiples of pi over 4, and in this case, pi over 6. So this is the cosine of pi over 6. So we have our angle pi over 6 drawn here in blue, and the cosine of that angle is just the x-coordinate of that point of intersection with the angle and the unit circle. This point here is the square root of 3 over 2, comma half. And we know that because we're familiar with our unit circle. So the cosine of this angle, pi over 6, must be that x-coordinate, square root of 3 over 2. Let's take the tangent of the arc cosine of rad 3 over 2. So making sense of this problem before we solve it, arc cosine of square root of 3 over 2 is going to be an angle. Then we're going to take the tangent of that angle, and tangent, we're familiar with SOHCAHTOA, and tangent of an angle given a right triangle is the opposite over the adjacent. We're more familiar now with that tangent of an angle is going to represent the y over the x, or the slope of that angle. So the range of tangent is all reals. Remember the tangent function. I'll draw it here. This is just part of the tangent function. But the range is all reals. So the answer to this problem could be anything. So arc cosine of this input, square root of 3 over 2, the square root of 3 over 2 represents an x-coordinate on the unit circle. So there's 2 places, 2 points with x-coordinates of square root of 3 over 2, positive square root of 3 over 2. Now, as we learned in the previous section, previous video, The outputs for arc cosine are between 0, so like 0 pi, that's 0, to pi. So our answer must be this angle in blue, which again happens to be pi over 6. Now I would love it if you were familiar with that angle and you knew that slope is 1 over the square root of 3. Or you can rationalize that denominator and say that it's square root of 3 over 3. Those are the same values, just one has a rational denominator. If you're not sure how I got this point here is square root of 3 over 2 comma half. Now the tangent of this angle is equal to the y-coordinate divided by the x, the rise over the run. I could draw a triangle here and help you see that and label that angle pi over 6. But the tangent of this angle is the opposite, the y value, divided by the adjacent, the x value. So we have 1/2. Since we're dividing, I'm going to go ahead and multiply by the reciprocals. The 2's will cancel, and we're left with 1 over the square root of 3. If we keep doing this process over and over and over again with these same values, 1/2 divided by square root of 3 over 2, we should hopefully see that that's the slope of that angle pi over 6. We're hopefully familiar with that the slope of the angle pi over 4 or the tangent pi over 4 is 1. And then the angle pi over 3, the tangent of that or the slope of that angle is the square root of 3. If you take the reciprocal of this, you just get square root of 3. If you just switched up this y-coordinate and made the x, because that's what this point is here, where pi over 3 intersects unit circle, it's 1/2 comma square root of 3 over 2. So everything's just going to get flipped. And it makes sense that this angle pi over 3 is steeper than this angle pi over 4, which has a slope of 1. Okay. Let's do the sine. Of the arc cosine of negative 1/2. So again, let's make sense of this problem before we solve it. Arc cosine, that's going to output an angle. So the answer to this part, I'll highlight this in blue. This is an angle. The sine of an angle has to be a value in between or including negative 1 to 1. It goes back to the range of sine. The outputs of sine have to be negative 1 to 1. So I'm going to draw a unit circle. Again, the radius is 1. So for context, this point over here would be negative 1 comma 0. This point up here is 0 comma 1. Now arc cosine, when we see arc cosine, this input right here is an x coordinate on the unit circle of a negative 1/2. So I'm going to put a point here at negative 1/2, and there's also another point that has an x coordinate negative 1/2. Sure, both these points have an x coordinate of negative 1/2, but their y coordinates are opposite. One is square root of 3 over 2, and the other one's negative square root of 3 over 2. Now arc cosine must output values between 0, we'll put 0 pi, 0 pi to pi. So this arc cosine has to be this angle in blue. You actually don't have to even know what that angle is. As long as you know the sine of that angle. Do you know the sine which represents the y-coordinate of that angle? If this point here is negative 1/2 comma square root of 3 over 2, then you know the answer to this problem is the sine of this angle is that y-coordinate, which is square root of 3 over 2. So you technically don't have to know that the arc cosine of negative 1/2 is 2/3 pi. But you should know that. So I can fill in this step here, but you really don't need this step. All right. Let's take the cosine of the arc tangent of negative 1. So again, the inverse trig functions, like this right here, the inverse of tangent or arctangent, outputs angles. So we're making sense of this problem before we solve it. So this arctangent -1 will be an angle. And then we take the cosine of an angle. So your answer better be in between -1 and 1. It's a bummer when students confuse the ideas. And when the problem says sine of something, cosine of something, the answer better be for sine and cosine a value in between -1 and 1. Sometimes people get these confused and they put angles for their answers to these, but no. It's only this part here, the arctangent, that will output an angle. And then the cosine of that angle will be the x-coordinate on the unit circle. So I'm going to draw arctangent represents, this -1 represents the slope. So I'm going to draw angles with the slope of -1. Now, from a previous lesson video, you have to know that arctangent of a value has to output a number or an angle between -π/2 and +π/2. It's an inverse trig function, so it can only have one output. So this angle in blue is in between -π/2 and π/2. The cosine of this angle will be the x-coordinate of that point on the unit circle. This point is square root of 2/2, comma, negative square root of 2/2. So the cosine of this angle is the x-coordinate, which is rad 2/2. So you technically don't have to know what arctangent -1 is in order to get the answer to this problem. But you should be able to evaluate arctangent -1. Again, it has to be this angle in blue. You'd be incorrect if you said it was 7π/4. Sure, 7π/4, the terminal side of the angle is there, but it's not in between -π/2 and π/2. So our angle here from 0 is going to be -π/4. So if you prefer to show this middle step, the cosine, this is the cosine of -π/4. Again, when you see an inverse trig function, the output's an angle. Inverse trig function, this outputs an angle. Inverse trig function, this outputs an angle. But now its tangent of an angle will be the slope of that angle. The sine of the angle is the y-coordinate where that angle intersects the unit circle. Cosine of the angle is the x-coordinate where the angle intersects the unit circle. All right, let's do one more with tangent. Okay, so making sense of this problem before we solve it. The arctangent of square root of 3 has to output an angle. The answer to this part here, I'll highlight it in blue. This is an angle. The sine of these angles must be a value in between or including -1 to 1. So here's our unit circle. I'm familiar with the angles that have a slope. This is arctangent, so this square root of 3 represents the slope of the angles. I'm familiar, hopefully you're also familiar with angles that have a slope of square root of 3. So the tangent of π/3, that equals square root of 3. This angle in red right here could be 4/3 pi. I say could be, like what? It can't be. No, it could be like if I start at 0 here and I go this direction, it's -2/3 pi to this terminal side. So the tangent, let's go back to 4/3 pi equals square root of 3. The tangent of -2/3 pi is square root of 3. So arctangent has to have exactly one output, and it has to, because it's a function, so it has to be between -π/2 to π/2. If you're curious, why is it those values? Like I said, there's a video I posted on why the range, the outputs of arctangent are between negative pi over 2 and pi over 2. So I want to know the sine or the y-coordinate where this angle intersects the unit circle. And we know it's this angle in blue here. That y-coordinate, well, let me label this point. It's 1/2, comma, square root of 3 over 2. We have to be familiar with the unit circle and that point and that angle. So the sine of this angle in blue is that y-coordinate, which is square root of 3 over 2. You don't actually have to know what the angle is to get this answer correct, but that angle in blue is pi over 3. So you have to be familiar with angles that are multiples of pi over 6 and pi over 4. And pi over 3 is a multiple of pi over 6. Okay, I just want to go over something that I didn't go over in the previous video. Is if we had to evaluate the arc sine of 2, what would the answer be to this? Well, we would draw our unit circle. The answer is supposed to be a value between and including negative pi over 2 to positive pi over 2, because that's what arc sine of values will output. Now, our unit circle has a point here at 1, 0. This point is 0, 1. Now, this is saying there is a y-coordinate on the unit circle with a value of 2. That's impossible. If this is 0, 1, 0, 2 is somewhere up here with a y value of 2, or any value with a y value of 2 would have to be up here somewhere. Here's another way to explain it. The sine function. I know this says arc sine, but sine, let me draw a little sketch here. The sine function goes up to 1 and down to negative 1. That's the range of sine. The range of sine, those y values become the inputs of arc sine. So you can only output values in between and including negative 1 to 1 into arc sine. So in this case, I'm sorry, but this will be undefined. The arc sine of 2 is undefined. Let's go with the arc cosine of negative 3. So this arc cosine, it should output an angle between 0 and pi, and it could include 0 and pi as well. And so I'm thinking, okay, cosine, this negative 3 represents an x coordinate on the unit circle. But it's impossible. There can't be an x coordinate of negative 3 on the unit circle. If this is negative 1 right here, negative 3 would be all the way over here. There's no point on the unit circle with an x coordinate of negative 3. So again, similarly to the sine function, this is a quick sketch of part of cosine. Sine and cosine have domain all reals, so this goes on forever. We did restrict cosine to 0 to pi. That way we'd pass the horizontal line test. That's what I talk about. That's the reason why the outputs for our cosine are between 0 and pi, because we had to restrict cosine. This is cosine of x right here at 0 and pi. That way this cosine of x graph will pass the horizontal line test, and therefore its inverse would be a function. Anyways, arc cosine of negative 3. If you look at the range of cosine, this is the cosine of x. It's negative 1 to 1. So that range must be the domain, the inputs of arc cosine. And so you're not allowed to plug in values into arc cosine that are between, that are outside of 1 or less than negative 1. So this problem is also undefined. Now, when it comes to arctangent of a value here, Hakuna Matata, it's no worries. Here's what I mean. Here is the graph of tangent of x. Now, this is just part of the graph. It keeps repeating this over and over and over again. if I were to draw more of this graph would not pass the horizontal line test, which means its inverse would not be a function. And so that's why we restricted tangent to be between negative pi over 2 and pi over 2. That way, this graph will pass the horizontal line test, tangent will, and therefore its inverse will be a function. The horizontal line test is used to determine if a function's inverse would be a function. All right, so the range of tangent is all reals. It goes up forever here and down forever. The range of tangent is all reals, which is why we can plug anything in here. We can take the arctangent of any value and there will be an output. There's no restrictions to that, unlike the previous two problems. Okay. Now I'm making one slight change. I'm writing arcsine as the outer function, and it's the arcsine of cosine of pi over 6. So all in the previous problems, it was reversed. We had arctangent here, and we took the sine of the inverse trig function. We took the cosine of the inverse trig function. Now we have the inverse trig function outside. Sorry. We have the inverse trig function outside, and we're taking, and inside we have the cosine of pi over 6. So this is our unit, our previous unit, which is cosine of pi over 6. That's just being able to evaluate the 6 trig functions of angles that are multiples of pi over 6. So I'm going to draw the angle pi over 6. This point here is square root of 3 over 2 comma 1/2. So this is the arcsine. Cosine of pi over 6 is going to be the x-coordinate where the angle intersects the unit circle. So the cosine of pi over 6 is the square root of 3 over 2. And now this problem goes back to the previous lesson. What's the arcsine of square root of 3 over 2? So on the unit circle, I'm going to draw the two locations, or the 2 points that have a y-coordinate of square root of 3 over 2. And the outputs for arcsine have to be in between or including negative pi over 2 to positive pi over 2. So the arcsine of square root of 3 over 2, that output has to be an angle. And that's that angle in blue, which is pi over 3. Okay, let's try another one. So we have the arc cosine of the tangent of 3 pi over 4. So let's make sense of this problem before we solve it. The tangent of 3 pi over 4, that's going to be a slope of that angle 3 pi over 4. And then we're going to take the arc cosine of that value. And our output of arc cosine will be an angle, but specifically an angle between or including 0 to pi. So I'm going to draw the angle 3 pi over 4. So that's 3/4 pi is right there. Now the slope of that angle is negative. It's going to be -1. If you're not sure. We're just familiar with those angles and those slopes. My students are, but that point is negative rad 2 over 2, comma rad 2 over 2. And so if you had to take the tangent of this angle, you could draw a right triangle and do the opposite over adjacent. And you're going to recognize it's just the y value divided by the x. And these are opposite numbers. So when you divide opposites, that result will be -1. Now I'm changing my mindset to tangent and slopes to now this says arc cosine. So now this -1 doesn't represent a slope anymore. It did a moment ago, but now in this context, we have to figure out what is the angle, because arc cosine outputs angles, that has an x coordinate of -1. So we're kind of switching gears here. We saw tangent, we're thinking slope. Now we see arc cosine, we're thinking this -1 is an x coordinate on the unit circle. There's only one location on the unit circle that has an x coordinate of -1, and it's right here. So the outputs of arc cosine have to be in between or including 0 to pi. So the answer to this problem will be pi. The cosine of pi is -1. All right, it's the arc tangent of the sine of pi over 2. So let's make sense of this problem before we solve it. The sine of the angle is going to be the y-coordinate where the angle intersects the unit circle. Then we're going to take the arc tangent of that value. So now that value, and when we see arc tangent, we're going to think of that value we have here I'm covering up as a slope. And arc tangent, we know our final answer to this problem must be an angle, because inverse trig functions like arc tangent have to output angles, specifically between -pi over 2 and +pi over 2. So I'm going to draw the unit circle. Here is the angle pi over 2. This point is 0, 1. So sine of pi over 2 is this y-coordinate here. Okay, now I'm switching gears. I'm pretty much ignoring everything that came before this. And now I'm seeing arc tangent. And now my mindset is, okay, arc tangent of 1. Because this is arc tangent, this 1 represents a slope. So now I'm going to forget all of this over here and just focus on this part here. Arc tangent of 1. So I'm going to draw an angle with a slope of 1. We should be familiar with the line y equals x, right? That has a slope of 1. We should be familiar with these angles. This is pi over 4. You call this angle in red here 5/4 pi. You call the one in red -3/4 pi. There's an infinite number of ways. If I can go here, this is pi over 4 and add 2 pi. There's another angle. You keep adding multiples of 2 pi and whatnot. But arc tangent has to be an angle between -pi over 2 to pi over 2. So it's only this one option. There will only be one option when you draw this, because inverse functions, and yes, inverse trig functions, have to have exactly one output, because the word function means each input has exactly one output. And so this angle here is pi over 4. All right, let's try another set of problems, a little bit different. This is the arc sine of the sine of 5 pi over 6. So let's make sense of this problem before we solve it. It's really tempting for students to say the answer to this problem is 5 pi over 6. And that's because they see sine, they see arc sine. Those are inverse functions, so they undo each other, and the result is 5 pi over 6 is what some students think. Unfortunately, that's wrong, and let me tell you why. The sine of 5 pi over 6 is the y-coordinate where the graph intersects the unit circle, okay? Then we take the arc sine of that y-coordinate, and you already know that arc sine has to output an angle between -pi over 2 and +pi over 2. So let me say it again in a different way. Arc sine cannot output an angle bigger than pi over 2. And 5/6 pi, let me draw that. So here's our unit circle. The angle 5/6 pi is right here. So that's beyond pi over 2. It's beyond -pi over 2. So that cannot be our answer. So all we have to do is do these problems like we did the first set. The sine of 5 pi over 6 is this y coordinate, which is a half. This x coordinate is negative square root of 3 over 2 comma 1 half. But the sine of 5 pi over 6 is this half. Now we have the arc sine of 1 half. So not only there's a point right here with a y coordinate of 1 half, because if we were just to totally ignore this and just do this, we can do that. Just ignore that previous unit circle. The way we did these problems the other day is we know that arc sine has to output an angle. This 1 half is a y coordinate. So I would draw one point here that has a y coordinate of a half and the other one over here. But because arc sine must output a value in between negative pi over 2 to positive pi over 2, our answer cannot be 5 pi over 6. It can't be this angle. It must be this one right here, which is pi over 6. Okay, let's do another one. The arc cosine of the cosine of negative pi over 3. Let's make sense of this problem before we solve it. Arc cosine is the very outer function. We have the arc cosine of something else. So I'm looking outside here. That means the answer to this problem, because we know arc cosine has to output angles in between or including 0 to pi. Our answer cannot be negative pi over 3. Students will see arc cosine, they'll see cosine, they'll think those go away because they're inverses, but arc cosine cannot output negative pi over 3. So let's just evaluate this first part. So I'm going to draw the angle negative pi over 3, so we're going to go clockwise. And negative pi over 3 is right here. Now cosine represents the x coordinate of this point on the unit circle, which is 1 half, comma. Yeah, this point is negative. The y value is negative square root of 3 over 2, but it doesn't come into play here. The cosine of this angle is just that x coordinate, which is 1 half. Now, ignore this, and let's just analyze this problem here. Our cosine must output an angle between 0 or pi. It can include 0, it can include pi. And the x coordinate is a half. So there's 2 points on the circle with an x coordinate of a half. So again, see this one here in the fourth quadrant? We have that one again right there, as we should. But our cosine must output angles between, I'll put 0 pi there, that's 0 to pi. So the answer to this must be the angle in blue. All right. We have the arc tangent of 4/3 pi. Students want to just say that these undo each other and we get 4/3 pi. I mean, that would be true if this angle is in between negative pi over 2 and pi over 2, because that is the possible outputs of arc tangent. Again, arc tangent outputs a value, an angle between negative pi over 2 and positive pi over 2, and so 4/3 pi is out of bounds. That's out of that interval. So let's go ahead and just evaluate this like we did the first set of problems. 4 pi over 3. It's going to be this angle right here. This is 1 and 1/3 pi. 3 divides into 4 one time, so 1 1/3 pi. So if I start at 0, this is 1 pi, plus I got to go 1/3 pi more. The slope of that angle, because we're familiar with that angle, I don't have to take the y coordinate divided by the x. You can. I hope you're just familiar that that slope is going to be positive square root of 3. It looks like the slope of that might be negative, but from left to right, you're increasing here. case you're confused how I got that, this point is negative 1/2, comma negative square root of 3 over 2. So the tangent of 4 pi over 3 is going to be the rise over the run, the y divided by the x. So we're going to multiply by the reciprocal, and we get negative square root of 3 over 2 times negative 2, and negative becomes a positive. Those 2's will cancel. We get positive rad 3. Now I'm going to go ahead and ignore that, circle and draw another one. I'm going to draw the angles that have a slope of rad 3. There's one here, the first quadrant. There's one here. Like, how did I know it was there? Well, I know pi over 4 has a slope of 1. And I'm familiar with this slope. You have to be familiar with the slope of pi, or I should say 0, pi over 6, pi over 4, and pi over 3. And then pi over 2, that tangent pi over 2 is undefined. So if I know tangent pi over 4 is 1, square root of 3 is bigger than 1, so this has to be steeper. And so it's that angle pi over 3. Now, the arc tangent will output the angles in the fourth and first quadrant, more specifically between negative pi over 2 and positive pi over 2. So this answer is pi over 3. All right, there's one more type of problem that I forgot about that we need to go over as well. All right, so the directions are still evaluate. That's been our directions for every single problem. This is the cosine of the arc sine of 1/3. Now, I'm only familiar with these values here: 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. I'm only familiar with plus or minus those values, which are points of intersection with the angles that are multiples of pi over 6 and pi over 4. So when I see arc sine, this 1/3 has to represent a y coordinate on a unit circle. And I'm not familiar with that value. It's not one of these here. So I could approximate what arc sine of 1/3 is. It's definitely going to be in the first quadrant between 0 and pi over 2. So we would need a calculator to evaluate arc sine of 1/3. But this problem isn't asking for arc sine of 1/3. It's asking for the cosine of arc sine. So I'm going to actually draw not a unit circle anymore, but just an angle in the first quadrant. I'm drawing an angle in the first quadrant because arc sine has to output a value between between negative pi over 2 and pi over 2. So for this case, it would be between 0 and pi over 2. So I'm just going to draw a triangle. Now my preference is to let this arc sine of 1/3 be equal to theta. Now sine of theta then would equal 1/3. So if I was doing this process the same way as the unit circles, I would have my unit circle here. This point is 1, 0, a y value of 1/3 that's less than a half. So this angle would be between 0 and pi over 6, between 0 and 30 degrees. Let's check it out. Sure enough, pi over 6, that's 180 degrees divided by 6 is 30 degrees. This angle, arc sine of 1/3, I'm not familiar with that angle, but it's between 0 and 30 degrees. So this point would be x, 1/3. Now I could use Pythagorean theorem and draw a right triangle here. And I know the x, this is x, the y is 1/3, the radius is always 1. Because it's a unit circle, the radius is 1. So I could do x squared plus 1/3 squared equals 1 squared to figure out what x is. I need to know what x is because it's the cosine of the angle would be this x coordinate on the unit circle. I'd rather just make this 3 my hypotenuse. So rather than having a hypotenuse of 1 and doing a unit circle, I'm really just extending this angle and drawing a circle with radius 3. Whoops. And I'm basically drawing same angle, but now I have a bigger triangle. I'm calling the opposite side 1 and 3 the hypotenuse. So just so it doesn't look so confusing, I'm going to get rid of that. So sine of theta is equal to 1 over 3. Now I'm going to find this missing side, this missing x value here. So x squared plus 1 squared equals 3 squared. X squared equals, this is 9 minus 1 is 8. X equals plus or minus 2 times the square root of 2. The square root of 8 can be rewritten as 2 times the square root of 2. Now, in the context of this problem, this is a point right here. We're going to the right and then up. So it's from the origin, since we're going to the right, this point is positive 2 rad 2, comma 1. This is definitely not the unit circle. I'm not going to say the cosine of this angle is the x coordinate. Nope, that only applies to when it's the unit circle. So the cosine, going back to SOHCAHTOA, cosine of an angle is equal to the adjacent side. And we just found that this was 2 rad 2. Now, first off, you know the answer can't be just 2 rad 2 because cosine, remember the cosine function, it goes up to 1 and down to negative 1. It can never output a value bigger than 1. And that's bigger than 1. It's because our radius isn't 1, it's 3 here. So you divide by 3. So if you wanted to, you could do the unit circle approach. The y value is 1/3, but now you're taking x squared plus 1/3 squared equals 1 squared, and you'll get 2 rad 2 over 3. 2 rad 2 over 3 would be that x coordinate right here. All right, I look at arc cosine of square root 3 over 4. That has to output an angle between or including 0 to pi. Sine of that angle has to be a value between or including negative 1 to 1. So we're expecting an answer between negative 1 and 1. I'm not familiar with that value. Square root of 3 over 4, it's not one of the coordinates where the angles that are multiples of pi over 4 and pi over 6 intersect the unit circle. So arc cosine outputs an angle. I'm going to call this output theta. Let's pretend this outputs the angle theta. Square root of 3 over 4 is an x coordinate. That's positive. So I'm going to draw this angle in the first quadrant because arc cosine can only output angles in the first or second between 0 and pi, and this is positive. So it must be here in the first. Now, I would prefer not to make this x coordinate square root of 3 over 4. I'd prefer to go with a hypotenuse. Let's call this square root of 3 the adjacent side and the 4 the hypotenuse side on the right triangle. So cosine of theta equals the square root of 3 over 4. So again, if you wanted to, you could draw a unit circle. This radius would be 1, and this x value here, the side length, would be the square root of 3 over 4. Now I'm going to find this missing side. Why? I need to know that because the sine of the angle is going to be the opposite over hypotenuse. So we have the square root of 3 squared plus y squared equals 4 squared. So we get 3 plus y squared equals 16. That's y squared equals 13 when I subtract 3 to both sides. Y equals plus or minus the square root of 13. In the context of this problem, we have a point right here. From the origin, we're going right square root of 3. And we're going up. That's how I know this coordinate is going to be positive square root of 13, because we're going up. Now, sine of the angle. You're like, it's the y value, it's the y value. Well, that's true. When the angle intersects a unit circle and that y value is a point on the unit circle. But you know the sine function, it goes up to 1 and down to -1. Sine cannot output a value bigger than 1, so that's off. It's because this is not a radius of 1. This point, rad 3, 13, would be beyond, above the unit circle. So the sine of this angle is the y coordinate divided by the hypotenuse of 4. And now this value is in between, or I should say it's less than 1 and obviously bigger than -1. Okay, so 2/5 represents a y coordinate on the unit circle. Arc sine will be an angle in between or including -2 to power 2. Secant. So when I see the trig function secant, I think of the reciprocal of cosine. So I'm going to find the cosine of this angle and then take the reciprocal of it. Now, I'm not familiar with a point on a unit circle with a y coordinate of 2/5. I'm just familiar with these values. So if I just asked you to evaluate arc sine of 2/5, you couldn't do that without a calculator. You could estimate it. But we have secant of that angle, so we only really need to know the reciprocal of the cosine of that angle. So I'm going to let this arc sine of 2/5, let this output an angle, let's call it theta. The arc sine of 2/5. So this implies the sine of theta equals 2/5. So this is the opposite side of the right triangle divided by the hypotenuse. The opposite divided by the hypotenuse. We're going to find the missing side. I'll call it x by using the Pythagorean theorem. X squared plus 2 squared equals 5 squared. X squared equals 21. You can see 25 here. That's a 4. Subtract 4 to both sides. You get x equals plus or minus the square root of 21. So I'm going to just evaluate what is the cosine of theta, because that's the reciprocal of secant. So the cosine of theta is the adjacent side divided by the hypotenuse. Again, the cosine of theta cannot output a value bigger than 1 nor smaller than -1, so it's good that this value is smaller than 1. Now secant of theta, secant of this angle, we're just going to take the reciprocal of this value or flip it. So it's 5 divided by the square root of 21. You don't have to rationalize the denominator. If you're in my class, if your teacher wants you to, that'd be 5 times the square root of 21 over 21. Now, arc tangent of -1/2. If you're like, oh, -1/2, I'm familiar with that value. It made our list up here. That's true. There's a half. But these represent the x and y coordinates in each circle. arctangent represents slopes of the angles. So we're only familiar with 0, 1 over rad 3, or you can call that the square root of 3 over 3. A slope of 1, a slope of rad 3, and then plus or minus those values, and then undefined, the tangent of power 2 is undefined. All right, so I'm not familiar with this slope. So I'm gonna call this arctangent angle theta. So this is an angle. Cosecant is the reciprocal of sine. So I'm gonna figure out what sine of theta is and then take the reciprocal of it. So I'm gonna draw this angle. The slope's -1/2, so the angle would have to be in the second or fourth quadrant. But we know arctangent cannot output an angle beyond power 2, nor less than negative power 2, so it has to be right here. Okay, I'm not going to draw the circle here, unit circle. I've stopped doing that once I wasn't familiar with the values. And you can if you want to. So here's theta. You have to remember the tangent of theta is going to be equal to the opposite over the adjacent. I know this says -1 here, but see this point down here? I'm going to the right and I'm going down. So I'm not going to, I mean, if I have -1, I'm not going to for sure say that's -1 for that y value. It technically is because it's down here, but let's say we put 1 over -2. Some might want to call this x squared -2, but you know for sure the graph's going, or from the origin, this point is to the right and then down. So tangent of theta is the opposite over the adjacent. The hypotenuse will always be positive. The hypotenuse is always positive. So we need to go ahead and figure out this hypotenuse. H squared is equal to 2 squared plus -1 squared. H squared equals 4 plus 1, that's 5. So H equals plus or minus square root of 5. If I solve that equation, in the context of all these problems, the hypotenuse, or if you think about it as the radius of the circle, is going to be the square root of 5. Cosecant is reciprocal of sine, so I'm thinking sine of theta. So SOHCAHTOA, sine of theta is the opposite over the hypotenuse, which implies the cosecant will equal the reciprocal of that. Again, sine of theta cannot output a value bigger than 1 or less than -1, and this number is not less than -1, so it's good.